Okay, so I already brought this up and I was like, we know in graph they really like working with the boundary cases, so the minimum or maximums. So we're going to bring in a definition here, which should be of no surprise to you, but the actual word may be. So we're going to have a thing called the chromatic number. And the chromatic number is usually represented by chi. But if you have already used like the Euler characteristic, the Euler characteristic often is represented by that chi as well. So you'll notice in some textbooks that they'll actually, or in some texts, they'll actually use your gamma kind of a situation to represent your chromatic number. So that's just something to be aware of. Your chromatic number symbol can change, and it's because, you know, your chi has already been taken by the Euler characteristic, which we spoke about in planar graphs. Okay, but what's important is what exactly is the chromatic number representing. So the chromatic number is the least K coloring possible for the graph. Okay, and we're going to refer to it as chi or gamma, but most of the time I'll refer to it as chi. So when we have, for example, you know, that graph earlier where we had this kind of a situation, and when we looked at it, we saw that it was 5 colorable, but it was also like 3 colorable. So the idea behind the chromatic number, it is the least K coloring possible for the graph. So again, we can just have a quick check that when we're going through this, you know, that the least color is 3. Can we make it 2? Let's actually just consider that. So we have that one as red, and then we have this one as green. Can the next one be green? No, because there is an adjacent vertex. So that one can be green, and then that can be blue, and that can be blue. So the chi for this particular graph is 3. So the chromatic number is a boundary point, is the least K coloring possible for the graph. Okay. So going to another example that you should be familiar with is the complete bipartite graph. So when you look at the complete bipartite graph, let's just go through this here. We now have, you know, that kind of a situation, and we know that with bipartite graphs, you know, these can all be red and these can all be blue. So the chi for bipartite graph is obviously equal to 2. And remember, when you first draw it, you could also draw it, you know, as this kind of a situation where you could have had this as green, this is yellow, this is red, this is blue, and this is purple. So your chromatic number is the least K coloring possible, and then you're also going to have a situation where your K coloring, when you look at a graph and it is, you know, it has 5 vertices, it can at least be 5 colorable kind of a situation. But it can be, it's obviously going to be less than 5 colorable or less than or equal to 5 colorable. And then your chromatic number is the actual least coloring possible for the graph. Now, one of the aspects to just take note of is if you have a subgraph inside your graph. So say, for example, you have, I'm trying to draw something slightly interesting. Well, actually, no, let's just go with this. So we have that kind of a graph. And we have a subgraph in that graph of just this situation. So we know we can have that one is purple, and that one is purple, and then that's blue, and that's blue. So we know that subgraph has, you know, a chi equal to 2. So we know that the larger graph has to have a coloring of greater than or equal to 2. So why? Because the subgraph has already indicated that there must be at least 2 colors occurring on it. Or we could take, you know, that middle part of it, if we take that part over there, kind of a situation, and Again, with, you know, looking at the adjacent vertices can't be the same color. We have this one can be green, this one can be green, and this one can be green, this one can be yellow, kind of a situation. We again can see that it has to be at least two colorable in regards to how we draw it. So it's not the best example, so let's just go on to a new page where I can give you better examples.